Hello students, welcome. In this session, we will see the network basics in distributed computing. So first of all, protocols. What is a protocol? Already you know protocol is a set of rules and that must be observed by participating computers. In a network, there are multiple computers. In order to communicate with other networked computer, each computer should follow certain rules. This is called a protocol. Okay. So, for example, HTTP Hypertext Transfer Protocol, it specifies the rules that must be observed between web browser and web server. Hypertext Transfer Protocol. So, this protocol is used to transfer the web pages. So, it will specify the rules that must be observed between web browser and web server process. So, next one, the network architecture. So, network architecture used to present the functionalities of a network. The classic network architecture called OSI architecture. So, open system interconnect. OSI reference model, already you know that it divides the complex functionalities of a network into 7 layers. Okay, but here is a simplified network architecture for the internet. It has 4 layers. Okay, it has 4 layers. So the internet network architecture, it has 4 layers of that is physical layer, internet layer, transport layer and application layer. Okay, the first one, the physical layer. So this physical layer provides functionalities for the transmission of signals. So these signals are a stream of data. So this stream of data from one computer to another. So the very first layer is physical layer. Here in this, data stream is transmitted to one computer to another in the form of signals. So the next layer is internet layer. Here data packet is addressed and delivered to a remote computer. So here in this layer, data signals are converted into data packets. So you know what is a packet? Packet is a piece of data. So each packet has its header, in that the address of sender and receiver computer. So in internet layer, data packets are addressed and delivered. So in physical layer, data is transmitted in the form of signals, and in internet layer, so these signals are converted into data packets. Okay, so the next layer is transport layer. So this layer delivers the data packet in a specific to a specific remote computer. So the transport layer is responsible to the proper delivery of data. Okay, so it will transport the data to remote computer. And finally, application layer. So it allows the messages to be exchanged between programs in support of an application such as www. So the application should provide user interface through which the messages can be viewed. So the last topmost layer is application layer, where the actual data is presented. Okay, so here the user interface should be provided in this application layer. Some applications are used to provide the user interface through which the messages can be viewed and accessed by the user. So this is about internet network architecture. Okay, so the next is network architecture protocols. So in this network architecture, so what are all the protocols are used? Okay, first one is IP, that is internet protocol. It uses particular naming scheme to identify computers on the network for routing the data. Okay, so what is that naming scheme? Already you know the naming scheme is means the domain name system. So each computer has its own IP address. So this IP address will be in the form of decimal dotted notation, like 192.168.38.02, like that. Okay, so the decimal dotted notation. This is the IP address. So the corresponding IP address is having its own name, which will be easy to remember. Easy to access than a decimal notation. So this is called naming system, domain name system. So the IP Internet Protocol is responsible for this DNS or domain name system or naming system uh, to identify computers on the network and for routing the data. Routing data means transferring one data to a specific network. So from one network to other network or source to destination. So that is called routing data. So next protocol is TCP. TCP is a transmission control protocol. At the transport layer, two protocols are used, TCP and UDP. See here, uh, in this internet network architecture, you have seen the transport layer. In this layer, these two protocols are used to transport data to the destination. Two protocols are TCP and UDP. So either TCP can be used or UDP can be used. TCP is a transmission control protocol and UDP is user datagram protocol, where this TCP is a connection oriented and UDP is connectionless. Connection oriented means TCP, that is a connection or delivery of data is guaranteed, and UDP there is no guarantee of delivery of data. Okay, you can use either TCP or UDP. TCP is reliable and UDP is unreliable. So at application layer, some protocols like FTP, HTTP, SNMP are used. SNMP is simple network mail protocols. These are all used at application layer of internet architecture. Okay, internet network architecture. So these are all the protocols, some protocols used in the internet network architecture. Okay, so now connection oriented versus connectionless communication. So what is a connection oriented, what is connectionless communication? In connection oriented, connection is established for for example, a phone call. First of all, a connection line is established, then data can be sent. So data here in the form of voice. Okay, phone call, so voice data can be sent on this connection repeatedly, and at the end the connection is terminated. So if you want to transmit data, again you will have to establish connection. This is a one form of connection oriented communication. Okay, so here a separate connection is established, but in connectionless communication, it involves no connection. Instead, data is sent a packet at a time. Each packet must be explicitly addressed by sender to receiver. This type is simpler to provide, hence there is no separate connection. So this type is simpler. Lack of connection may result in data packets being lost during delivery or delivered out. It may be delivered out of order. It will not be in that order in which it was sent. Okay, so the connectionless communication involves no connection. There will be no separate connection. Instead, each packet will be sent separately. Okay, each packet must be explicitly addressed and sent. Okay, so here connectionless, some example, maybe email or message. Email should be sent how one using the separate address, isn't it? Email will be sent separately using the address, and the address should be explicitly done. It should be explicitly addressed. And this connection oriented, it is a phone call. There will be a connection previously established, and connection oriented, it maintains a separate connection. This ensures packets are delivered safely in the order. So connection oriented is efficient and reliable. Connectionless is, it is less reliable or unreliable. Already you have seen here in transport layer we use two protocols, that is TCP and UDP. TCP is connection oriented, UDP is connectionless, isn't it? So connection oriented means there is a separate connection between the sender and receiver, and UDP means connectionless. There will be no separate connection. So separate connection oriented is efficient, connectionless will be there. We get some problems there. It will result in data packets being lost during delivery or delivered out of order. But in connection oriented, it will be in the same order and the delivery of data is guaranteed. So for connectionless, the example is message or email, and for connection oriented you can give a example of phone call. Okay, so here this is how the connection oriented and connectionless communication is done. See, the connection oriented communication, there is a single connection and data packets are sent in that using that connection. But in connectionless, each packet is sent separately, but each packet should be addressed. Okay, each packet should be addressed. See here, connection oriented is like a phone call, and connectionless communication is a like a email or message is sent separately, isn't it? So which one is reliable? First one, the connection oriented is reliable because there is a separate connection, so delivery of data is guaranteed, and connectionless is less, there is no guarantee of delivery of data. Okay, so now the network resources. The network resources are resources that are available to the participants of the distributed community. So participants of distributed community means the computers. For example, a file is also considered file as a resource, isn't it? So here some hardware such as computers and some equipment such as printers, cameras, scanners are called resources, and softwares like files or mailboxes, web documents are also resources, and some network services such as www, FTP, these are all called network resources. Okay, and these resources should be available to the distributed participants of distributed community. Participants of distributed community means the computers are interconnected in the distributed computing, isn't it? So these are the resources available to the computers that are connected in the network. Okay, so next one, DNS. What is a DNS? It is a domain name system. Already you know what is domain name system. That is a symbolic name for identifying a host in a network. So every domain name contains two or more components separated by dots. Okay, for example, acme.com. In this example, the last component .com is called top level domain. Okay, .com is top level domain. To the left of this name ACME, that is to the left of this name, that is ACME, it is called second level domain. Okay, ACME is called second level domain, .com is called top level domain, ACME is called second level domain, and also possible to have subdomain like marketing.acme.com or sales.acme.com. So this marketing or sales is called a subdomain, and domain names are not case sensitive. Okay, case sensitive means uppercase or lowercase, whichever it will take the same. Okay, the effect will be same. It is not case sensitive, it is case insensitive. Okay, so here there are some top level domain names, .com, .net. So these are called top level, isn't it? See here, acme.com, here .com is top level. So there are some top level domain names. .com, so this .com is used for some commercial entities. Commercial entity means profit earning entities. Okay, commercial entities, they are using .com, and .net, they are designated for organizations, they are directly involved in internet operations. So some organizations providing some network, they are using this .net domain. And next one, org, there are some organizations using the .org, that means non-profits. Okay, these organizations they are using .org, and .edu, that is for higher learning, and you must have seen some education engineering colleges, they are using .edu. .gov for government entities, and .mil for military purpose, and some country codes also used as top level domain names, for example .in for India, and .ca for Canada, and .jp for Japan. Okay, so these are all some top level domain names. So this is the domain name hierarchy. So under this root domain we have top level domains. See this .us or .com, .gov, .edu, mil, net, .org. These are all top level domains, isn't it? Under root domain, these are all top level domains. Under that you have second level domains. Already you have seen in here second level domain, that is acme.com. In that, acme is second level, .com is top level, acme is second level, isn't it? So here .gov.edu is top level, and ussb.edu, okay, that is second level. Next one, you can use have a subdomain also, that means cs.ucsb.edu. So cs, ece, or English, wireless, these are all called subdomains. That means cs.ucsb.edu. Okay, this is about domain name hierarchy. Okay.